time for another DraftScience video presentation. Appears to be recording. Anyway, so we will attempt more conversation with Robert Ritchie, but I don't think it's going to go anywhere because we don't have any similar starting points. Again, it's like an evolutionist arguing with a religious person, in the sense that I will argue, okay, that science requires limitations to what you accept as truth, and stories just aren't the truth. And I would argue that much of conventional physics is just storytelling. They've created a whole bunch of mechanisms that now they have to put in the story. Okay, they've accepted the existence of gingerbread, they've accepted the existence of witches. Now you have to have a conversation about, well, how can the witch have an oven, that she's burning children in, because the oven would have to be made out of gingerbread, and the gingerbread would fall apart, and the stuff doesn't start sticking together very well. What pieces of the puzzle you're putting together. So we don't have enough of a common understanding of what has been proven to exist, well established to exist as phenomenon. Okay, so I obviously don't believe in ESP particles. So entanglement is nonsense. A whole bunch of stuff is, in my opinion, just made up stories. But there really isn't any evidence demonstrating that that's the actual cause of an effect. And I've demonstrated by making some videos pointing out how the history of a lot of this physics is garbage. The whole Young experiment was junk the day it was drawn, in the sense it doesn't even get the right answers. And yet it's part of the established. They're established. You have to start here with this notion that somehow particles are waves. Or more specifically, their assertion that a wave can look like a particle. Particles can look like waves. Waves can't look like particles is really the premise. My argument. And that's a huge difference. When people start saying waves can be particle-like, no, they can't. Show me. Doesn't make any sense. Anyway, so we just don't have any, where's the room for conversation? There really isn't any. The reason why I responded to your video was because you made an assertion that you have found some new physics, that something nobody thought could happen can happen. And I would argue that, well, yeah, okay, show me. And no, you're going to wait until February, whatever the special date is for the special demonstration of the whatever it is. But that's it, frankly. I mean, I like talking about physics, but again, there's just no room for the conversation here because we don't believe in the same things. I believe the universe is made out of bits of momentum. And all the bits of the momentum can just be arranged in little subtle different ways, and things will happen, but it all moves on straight lines. Nothing goes out from the earth and then goes some other direction. You can't have two momentums. You can only have one. Those are the rules. And we just don't see the conversion of momentum, but there's a conversion, but it's always straight lines. But anyway. We'll play some of this, and we'll run into all of these obstacles. And again, I've pointed out, maybe you haven't heard it enough times, but I'm totally disinterested in cosmology as being a source of understanding the small universe. Why look at much bigger things? We have plenty of big things here to look at. Looking at gigantic celestial objects is just really no different than just looking at any object and saying, what is it? Because there's only... See, this is a starting point. See, in my opinion, there's one universe, the little one. The little one makes everything happen. It has to first happen to electrons and protons before it can happen to a person or a planet or anything bigger. Everything starts with the little stuff. The little stuff makes the big stuff. So there's only one universe. So again, if I can study a mouse, why would I study an elephant?
G'day viewers, and Gary, back here again. This is my rebuttal, round 2, episode 2, whatever you want to call it.
Okay.
No infinite cotton candy machine for you, Gary. I'm going to talk about pulsars
Well, why don't you talk about this cotton candy machine? Why don't you, I mean, I make it a joke, but whatever. I mean, that's my habit. Lighten things up a little. But I mean, you're claiming to have you found something that is a new phenomenon in physics, and it's one that's promising, again, something miraculous almost. This power source, and implying anyway. That we just turn the key and all of a sudden the car will start. We don't have to put any gas in. We don't have to worry about all this bullshit. So that's a pretty bold statement, and I would like you to talk about that. But instead, that's a big secret. Okay, blah 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 blah. And so instead, we're going to talk about things that I'm not terribly interested in, because they really don't have to do with the whole wave-particle duality, which is the source of all this bullshit in a sense. The whole quantum mechanics is based on. Or we're not going to talk about how vacuous it is to say bent space and tell me there's an inverse square law. Yeah, I know that. What's causing the effect? I don't, this conversation about the effect, we're going to give it a name. Bent space. There. Now we've described it. We've explained exactly how it works because we said the word bent space. Oh, bull. Yeah, not even close. So those are the things I want to talk about. But anyway, it's not about me. It's about you. Fine. Do what you want to do. I'm just saying this isn't going to be convincing. Because a Wikipedia page says so, just isn't going to work for me.
Magnetars and black holes.
Yes, like I could care less. I mean, frankly, the whole principle of a black hole, let's just understand some of the stuff that you people are buying into. Okay, they have it. Look, I can understand lots of things, but I can't understand black hole. So I could argue that there's the existence of a hydrogen atom. We could agree that we have this proton and we have an electron. Okay, so we have the element of an atom, and the neutron is the same thing, really. Okay, so you could argue that when it's this much distance, it's a hydrogen atom. When there's this much distance, we could say, oh, that's a neutron. So that might be the difference between the two. Maybe the neutron is spinning. Maybe that's actually a function, where the two things are spinning around each other. A little binary system. And therefore, when you look at it, you never get a view of it, right? You never get a view of it as being positive or negative because, frankly, it's always changing. And it's changing so quickly that you can't see the change. Therefore, it looks like purple from here, right? It just looks purple. No, if one was red and one was blue, you wouldn't be able to tell the difference. Okay, with a hydrogen atom, yes, because of the separation, it's not spinning, blah, blah, blah. So, I mean, I'd say hydrogen atoms essentially are required to function, that they actually are in pairs, So the hydrogen creates a stable configuration, okay, where it can stay in one piece and it doesn't have to be a neutron anymore. But anyway, back to neutrons. So you have a neutron. The idea is that you have something smaller. And that's all part of this thing, is how big it gets, right? Because we know if you want to make, you mix hydrogen and oxygen, what you're basically doing is separating these things. You're creating more space. You're making bigger and bigger atoms. And the bigger you make the atom, it's pressure. So that's kind of like what we're using for thrust. Is we're causing atoms to get bigger, take up more space, become less dense but more voluminous. All right, but that's the whole point here, right? Is when you get into this conversation about black holes, they're breaking the whole concept of volume, and size. So their physics is we don't pay any attention to distances and size, because they're just mathematically thinking of everything as a point source. So everything's just a little dot. Okay, everything isn't a something, because they think it's all wave mechanics and fields and all that kind of crap. So they think a field comes over here and hits this little tiny this speck, because it doesn't matter how big it is. If it's a gigantic field hitting it, it doesn't matter how big it is, right? So they think a photon is a giant field, and they think everything's a giant field. Well, obviously, if you don't think it's a giant field, if you think it's actually made of particles that have to move in straight lines. And see, this is where it gets into his stuff. I mean, he'll start talking about pulsars and sending, rays out of its, like laser beams are flying out of it. well, all of a sudden this theory goes to hell if you start making laser beams, right? This wave theory doesn't make much sense. Well, anyway, but we know that this thing can't be infinitesimally small, right? We know the electron can't be a nothing in terms of its size, its volume, because photons actually hit it. Energy does hit it. Okay, and the energy isn't some wavy, silly crap. I mean, it's stuff hitting it. So it has to have a size. But anyway, so they make everything in their math to have no size. So no matter what it is, it just has a charge. Like if I was going to draw the Earth and I'd say, oh, it has a certain charge, I'll just make it a tiny spot and I'll say it's a charge 57. And I'll say something else that's a charge. So they just make everything, they just pretend that the radiation doesn't have a real source or a size of its source. And it really, in my opinion, must. But anyway, so that's a starting point of understanding where we're just going left and right. There's no meeting. But anyway, so they're saying, okay, I can understand where you could say, okay, let's take this small thing, this neutron that's inside of the core of an atom, and the nucleus is small, and so we can get the idea that they're close together. So that all makes sense. And I can see stacking these neutrons on top of each other, that is having something like solid hydrogen, where you just stack a bunch of protons and neutrons. I could do them in two different colors, which that would illustrate the point. Well, you won't see it because it's too far away anyway. But you have these protons and neutrons and you arrange them very close to each other. They repel, but they attract. So you can keep some distance. So they're very dense. You can create matter in a very dense package. And so you have lots of mass. That is, you have lots of elements, electrons and protons, but you have them in a very small space. So that would be a neutron star. Because you've taken out the volume part and made just nucleuses. They're just atomic nucleuses essentially. Without the electrons forcing everything to be guarded by a negative field. See, the atoms are all negative on the outside, theoretically, because of the electrons. The electrons are guarding the nucleus. And the nucleus is positive and negative, but it's more positive than negative, okay, because it has 2 protons for every electron. So it has twice as much positive as it has negative, therefore it ends up being positive. So anyway, but that atomic structure means that atoms can't stick to each other very well. They have to find a niche. There has to be a place where there's an extra amount of positive showing, and then another atom can sneak in there and attach. All right. So those are the kind of basic rules. So the neutron star I can buy, but then you're going to have to say, well, magnetically, is it going to be magnetic this way? Is it going to be magnetic this way? It's going to have a geometry, and and then the whole argument about a moving electron is all of a sudden an energetic thing and it's going to create a whole bunch of energy. It can't create energy. It can only change how energy is, the energy comes in and the energy goes out is the argument. Everything that is material is getting hit by energy and it's absorbing it and then re-emitting it. It can't go nowhere. The energy has to go somewhere. So theoretically, it's certainly understandable that a neutron star could potentially collect energy on this surface and get rid of it out this surface and out the bottom surface. It could get rid of it in some other location. But it's not making energy, it's just changing where the energy goes. So that's not miraculous either. Now obviously though, if it's not reflecting any energy in these directions, its gravitational effect would be, well, it's not reflecting any energy, this way, which means it has 0 gravity. That is, it's really gravitational because it's not making any energy go back this way. So all the energy going this way ends up going this way. It means that there's no energy to go out that way, theoretically. And so they would be highly gravitational. Now, you want to call that a black hole, it's okay with me, but it doesn't deserve a name yet. But let's understand what they say, because again, their math is saying this whole thing is a point. They're turning everything into a point source. So they're pretending there's no matter here, and they just turn all of these electrons and protons into one point. They say that's all of it is on top of each other. That is, the electron is on top of the proton, is on top of the electron, is on top of the proton, is inside the proton. They're putting it all inside of one place. So yeah, they can have an infinite number of them because they're they're just putting them in the same place. I mean, it doesn't make any sense. There's nothing saying you can't put that many things inside of each other. I would say they can't put any of them inside of each other. That was wrong from the very beginning. The math was stupid to think you could put the electron and the proton in the same location in space. No, you can't do that. They do have to take up individual space. The star has to have a size. And part of it is it has to have a size because it has to collect energy. It can't produce energy if it doesn't collect energy. So if it doesn't have a size, it can't possibly absorb any energy from space. If I make this tiny, very small, it can't reflect any light to you, right? Well, it also can't create any gravity, and it can't get to a lot of things. So it has to have a size, or it collects nothing from the universe. So you're telling me I have to accept the existence of this single point that has all the electrons, a gazillion, 1 million solar masses worth of mass inside of one single point? No, I don't believe that's a fact. I think that's just a story they tell. I don't think you have any reason, any proof you can provide to make me think this makes any sense, because they could do it mathematically, because they could just say, mass, location density 0. Because they could write it means it exists that way? No. So just trying to get to the point where, I understand that the universe is being mechanical and discrete. It's made out of discrete, okay? It's made out of little pieces of momentum going very, very fast, the speed of force, okay? And you can arrange them differently. And it has matter components, electrons and protons. And that's it. There's no neutrinos, none of that stuff. Neutrinos going the speed of light, well, then it's a force. It's not matter. All right? And it's just another form of what makes gravity. So I could argue that neutrinos are just gravity. The sun is producing fewer of them than the empty space next to the sun. That would be my argument. All right. Sheesh. So, continuing.
And we're going to apply some numbers, some real numbers, and we're going to go over a few points of contention that we have.
I don't think that'll happen.
And obviously there are no field lines in space. They were drawn to show the interaction between the gravitons and the mass.
I understand, but they didn't show it in a coherent way. Okay, so I try to point that out. That you can't. It's a contradiction, essentially, is what I'm arguing. You're drawing it in a contradicting way that can't possibly make any fluid sense. Okay, so I'll redraw what you drew and point out to you how you can't do that. All right. I should have made my eraser, but I didn't do it. All right. Anyway. So you drew a mass, and then you said there's a place out here, and then you drew an arrow on it. All right. So you're saying something's going this way in some way, and then it's going this way. Those are two different motions. One thing can't have two different motions. You can understand it as having a composite of impact. That is, when it hits something, you can convert what it does. Okay, you can say, well, it has a component going this way and it has a component going this way. You can do that, but it's going to leave with one vector. There's not going to be two vectors. It's not going to do two movements. It's not going to say, I remember I'm supposed to do this. Go both ways. It's not going to do that. I throw a wrench in space, right? Me and another guy are moving around the Earth in orbit, together. And I throw a wrench. The wrench goes in a straight line that way, okay, because I'm moving. And it has that momentum. And then I add a new momentum going towards the other guy. It's going to add up the two and send the wrench that way. The wrench isn't going to herky-jerky its way there. No, it's going to go one vector to the other guy. So this Doesn't say anything. Is this the speed? If it's going the speed of light this way, or is it going the speed of light this way? Because it can't go the speed of light both ways. It can't do that. So if you're going to say that's what it does, then you're going to have to say, well, it does this. Well, then it can't be moving the speed of light, because if it got here at the speed of light, it had to take this longer path, then it has to be going faster than the speed of light. It doesn't make any, I'm just saying, it doesn't make any sense to me. So if you're going to say something has two motions, that there's motion this way and there's motion going out this way, then you have to explain it. Because no thing can do that. A single thing can't do both of those motions at the same time. Can't do it.
That's all. And my argument is that all these forces interact at 90 degrees.
Well, I would argue that there's clearly a 90-degree component of electromagnetism, and I've sort of explained in my theory it's a simple idea. There's two different forces. The one force causes straight momentum, the other force just gets deflected at 90 degrees. So yeah, I believe there's a 90-degree component, but they all don't do that. They clearly, some of them have obviously no 90-degree component. I would argue that when a photon hits you, it's pushing you, period. Okay, it's not 90 degree.
There's so many examples in real life.
I would argue there's just as many examples of momentum being conveyed quite literally in a straight line in the direction of the momentum as there are examples of something that should have momentum being turned. So yes, both of those are possibilities. That's why there's a 2 in my physics for two interactions, because one interaction is momentum created in the object and the other interaction is a deflection of the force.
The second point of contention is I'll say that generally light will travel faster than neutrinos.
Okay, so I don't even know why you think this would be an interesting conversation, and like you've done any testing or you have any evidence for any of this stuff. I don't even think there is such a thing as technically a neutrino. I think it's just bullshit. But even if I did believe in it, I don't believe you can do this testing of how fast they're going or compare them to light or any of this crap. And why would there's such an overwhelming amount of evidence that the speed of light, the speed of force, is a consistent thing. And there's every bit of evidence that all of the forces, all of the stuff moving very, very fast, are all moving very, very fast at exactly the same speed. And the only thing you can change is their path. So you can slow them down by causing them to travel a larger path or to move matter, but you can't slow them down in the sense of in free space they all have the same speed.
Except through matter, where neutrinos win the race. I'm not saying anything's travelling faster than light at this point. Okay? So just get that concrete in your head.
You're saying that it's going subtly slower. Who cares? Frankly, if it even happened, I wouldn't care, but I don't believe they ever slowed down. I'm just saying that, of course, if a piece of force has to move a piece of matter, and the matter is moving less than the speed of the force has clearly been slowed down. But to argue that the speed of the force changed would be kind of stupid. It's just that it's carrying more weight, and so it can't progress as fast. But its feet are moving, its energy, its engine is moving just as fast. It's like a car towing a trailer. It can't go as fast. You press the accelerator halfway down. It doesn't go as fast. Okay, it doesn't mean that the engine isn't running just as fast.
Neutrinos will win the race through a bunch of mountains or mass or whatever. They have done the experiment. It was through the Italian Alps.
Yeah, whatever. They've done an experiment. You say you understand every detail of it and that you're sure it's correct. I would say they don't know what the fuck they're doing, and they're just saying, oh, we have a scintillator and we made it go bleep, a little photon popped out of it. And that means a neutrino went through it. Yeah, sure it did.
From memory? Okay. Magnets. If you rotate the magnets 90 degrees from what they are, your generator won't work. Your magnetic circuit won't be inducing a voltage in the windings. So, right.
So, right. So what? I mean, how's that? What is that? You know, who's disputing that? So again, your argument is for what purpose? To say that everything has a 90-degree component? Well, that's not everything, is it? A magnet certainly isn't everything. I'm conceding it's a dipole. Dipoles have arrangements. Okay, it's a dipole. It can be in a configuration, and depending on the configuration, it'll change how it works. That's right. No surprise.
Point of contention number 4. Your straight line theory works in most, but not all instances.
Okay, well, you won't show me that, so fine. So until I see it, I'm saying says you. There, that's my argument to that. Says you.
And they've proven black holes exist.
No, they haven't come anywhere close to what should be the term proven. So you might as well just say, oh, they proved Jesus exists because they found the Shroud of Turin, you know, or some other bullshit. Now, not proof. So, whatever. Again, if that's your premise, I have to believe in an infinitesimally small, infinitely small particle that contains the mass of 1,000,000 suns. No, I don't have to believe that. You don't have enough evidence to force me to do that, to say, oh, I'm not being reasonable because I don't believe in your, whatever it is, your compound superparticle. Yeah, I don't believe it exists. I believe that's crap.
There's no doubt about that. No,
fuck you. When do you want me to say this shit like that? You really think you or anyone else has proven, okay, that you can put an electron inside of a proton, inside of another electron, inside of another proton, inside of another electron, and do that a gazillion, trillion, zillion times? You really believe you can do that? I don't think you can.
I had that set in my head, and I'll actually argue the physics of black holes with physicists because I believe they have it wrong.
Oh, whoop-de-doo. How do they have it wrong? You're calling it a black hole. What's the difference? What's the difference between your black hole and their silly black hole?
They keep quoting infinity. You got to...
Oh, and what's the difference? I mean, really, realistically, what's the difference between if you shoved all the electrons into something this big or you shoved them into something this big? I mean, my argument is you can't do that. You can't put 1,000,000 solar masses in here. You can't do it.
One makes mistakes, and I will admit that I made a mistake in my description of the 3 particles I described as massless particles. And it appears that you still don't understand the
Yes, that's right. I have no will or desire to understand anything that violates the fundamental law of momentum, which is you have to have a mass component. If you don't have a mass component, you don't have any momentum. You can't cause an electron to move. You can't cause anything to happen to anything if you don't have any momentum. So it's just ridiculous, in my opinion, to break a perfectly good formula, MB, for momentum, a perfectly good description of energy, and say, I have massless energy. Oh, screw that. That's just silly.
Concept of a massless particle. Right, let's get back to pulsars. You claim...
I don't care. I mean, it's what I claim. I don't care. Again, you're sitting here, let's go look at something 5 billion light years away and see if we can figure out how reality works. No, I say let's look at things really much closer. Let's not go 5 billion. Let's not try to see 5 billion light years away when we can look at something really close.
They're just binary objects. Only very few pulsars are binary objects.
Says you. So again, you just don't have any evidence. The fact that there are pulsars that are binary indicates that it works. That being binary enables a pulsar to be a pulsar in some circumstances. It's the whole reason why the pulsar is pulsaring. So clearly, you don't have any photographs close enough to know. You really don't. You can't tell if there was, if Jupiter, before we did radar on it, but I mean, if you just looked at Jupiter, could you really tell that there isn't anything orbiting inside the atmosphere? No. So, I mean, you're going to tell me that you can look at something a billion light years away and you can tell whether it has stuff inside of it that's binary. I don't think you can.
Mainly they're single neutron stars, and they rotate at various angular velocities, and they do follow the laws of the conservation of momentum and conservation of angular momentum. That is, as they are shrinking, they're rotating.
Now, well, they have to be rotating in two planes for this theory to make any sense. So what they're saying is the pulsar is sitting here, right, and it's spinning. Well, but it's not spinning centered. Okay, so it's spinning turned like the Earth on an axis, and so now it's rotating this way. So its poles are now spinning. So it's not spinning on its poles, it's spinning asymmetric to its poles. So then this pole is doing this thing. So they're saying, yeah, some of them we can see because they're pointed right at us. Some of them we only see part of their cycle because they're not pointed right at us. And all of that would mean that the pulsar spin rate has nothing to do. See, this is where their own theory doesn't make much sense, because obviously if I change how it's pointed at me, I'll change how many seconds or milliseconds between the pulses. See, if the more it's not facing me, right, the further it appears, the time cycle, and the more it's pointed at me, the more likely, the faster it's going to seem. But that's all, But whatever. I don't care, frankly. So yeah, that's the subject that's interesting to you because you spend a lot of times in observatories manipulating these barely viewable images. Fine. Whatever.
Velocity increases. So, and as I said about magnons, that's what I call the magnetic particles in a magnetic field. Obviously my theory is not complete yet, but it's more complete than anyone else has. In a pulsar...
Says you again.
They actually accelerated, like a linear accelerator, and some of the particles escape.
The whole linear accelerator is kind of doubtable, frankly, if you study them, right? I mean, I look into it a little bit, and you find out that they're not even detecting charge. They start off when they are accelerating the electrons not terribly quickly. They're counting how much charge is piling up, and then as they start turning on all the other accelerators to accelerate them more and more and more and more and more, all of a sudden they just start detecting heat. So that's kind of funny, right? In my opinion. And the electrons that start off going like 97% of the speed of light, and then they get up to 98%, 99. They're only incrementally going up tiny little percentages of the speed of light, but getting to nearly the speed of light, or 80% of the speed of light, is really easy. You just need 1,000 volts, boom, I'm going almost the speed of light. So that's the part that doesn't make much sense.
They absorb that much energy in their acceleration that they are accelerated into X-rays and gamma rays.
So he's saying that acceleration has something to do with gamma ray or X-ray, when clearly they're all moving the same speed. It's not about accelerating. It's about frequency between clumps of energy. So you have to understand the frequency component. So for you to tell me that frequency is speed, well, that's not true. Everybody knows that's not true. I mean, the radio waves are going the same speed as the visible photons. They get from here to there in the same speed. So you can't sit there and say the frequency is speed. So that's kind of confusing two subjects. How does accelerating increase frequency? That's what you'd have to point out.
Now, the more powerful a pulsar, the smaller its radius, and it has a proportional increase in density.
Says you, blah, 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 blah. Who cares?
This is borne out by the study of many pulsars, and we can extrapolate from the current data set.
The current data set sucks, so that's the truth of it. Okay, they're not very visible. There's none of them really close. Okay, so you can't get a really good look at one. So again, this is just all You think this is where physics should waste their time, is studying pulsars. No, I think they ought to study magnets and two-slit experiments. And they ought to figure out how momentum works, and figure out that 1/2 mv squared is the silliest and stupidest mistake, the most obvious silly mistake physics ever made. There's just no justification for it. I mean, zero justification. I mean, no rational argument has been presented to me showing how this is a good equation. Like it somehow gets to the essence of energy when it's insanely silly. It basically says, yes, if you want free energy, just bang big things into little things and you win all the time. You just get free energy.
And I will tell you right now that once the Schwarzschild radius increased...
Oh, who cares about that nonsense? Again, this just has to do with the Schwarzschild radius, just has to do with this whole infinity crap. Let's put a whole bunch of matter into a single point. No, let's not, because it's silly.
This is above the radius of the star, that's when you get your black hole. So that's, as soon as the event horizon is above the physical boundary of the planet, it won't let light escape. And I've watched plenty of videos and I've studied this for years, and you really got to study it and understand it.
Oh, whatever. Yeah, bull fucking shit. That's all I have to say. Bullshit. Study what? You don't have anything. You got nothing. You have gravity existing in space, really far away, and you're telling me you know what caused it. I would argue they don't even know what galaxies are. I mean, galaxies clearly aren't anything like a solar system. A solar system is incredibly uneven. There's all kinds of, there's Saturn's over here. Sometimes they line up, but most of the time Pluto's over here and Saturn's over here and Jupiter's over here. There's no continuity, no symmetry. All right? And what are galaxies? Symmetry all over the place. I mean, that's the whole point of a galaxy is the fact that it's symmetrical. Clearly the arms are rotating around the arms. They're clearly just showing you how a binary system works.
You watch the tensor equations and they'll start saying, you put infinity in here, and this is my point of contention with conventional physics is you cannot use the term infinity. You can approach it.
Oh, what's the difference? Approach infinity. What the fuck is the difference? You're saying, well, no, you can have a well that goes 10 trillion, zillion, gazillion, bazillion miles, but you can't have one that goes 10 billion, gazillion miles times 2. Oh, okay. I reject the whole idea that you can make your well, as deep as you want. No, you can't. And you can't certainly make it insanely deep. There's only so much earth, and then you pop out the other side. That's it. You're done.
Infinity. But even if you put every particle in our known observable universe, it's still nowhere near infinity. I worked with numbers up to, I think it was 1.6 times 10 to the 1018th power, and the degree of...
That's just a waste of time, frankly, so I don't know why you would do that. It's like, why don't you just waste your time trying to chew your fingers off? Hey.
Certainty for the answer was something like 1.6 times 10 to the 120th power. That's a huge error factor, huge. So once you get to those super huge numbers, you just have to stop and say, no, enough's enough, that's out of bounds. The error factor is just too big. But getting back to what you call these ant pincers, now you could dig these up in your backyard and get a pellet.
Bet I can't. But whatever. So that's going to tell us what they are. Let's see.
Paleontologist out, and you get two paleontologists. One guy will tell you, that's a dinosaur tooth and it belongs.
All right, I bet you they won't do that. Okay, I bet you there's an answer to what they are, like cow horns or something. I mean, I bet you there's a real answer, and it's based on finding the whole animal, because the bones, the horns, the teeth are all like bones. They're going to get preserved, so they know what they came from. So I bet I'm not going to get two answers. Bet you I'm not.
To a the dinosaur that lived here 67.3 million years ago, and it had feathers and this and that, and they'll make the complete wrong conclusion based on the tiniest piece of evidence.
Okay. No, it's not really okay. You're just projecting now. You're projecting. Nobody's figured out what these stupid things are. You say you can dig them up in your backyard, fine. I'm sure it's understood what they're from. And you're saying, no, there's all kinds of uncertainty. I don't think there's any uncertainty. I think you're telling a story.
The other guy will come along and he'll go, no, that's a modern tooth. It looks like a whale tooth, which it is.
A wild tooth? I guess I gotta go back. Too bad these Australians, don't really speak English.
Which it is. Their sperm whale tooth, which it is. Their sperm whale teeth.
Spoon whale teeth. I don't know. So, whatever. I don't think there's anything in Australia that has teeth that big, but whatever, currently. But whatever.
So we'll keep them. They're my little. They're my devil's horns, to speak.
I don't know what that means either. Horny devils. I don't think there's any point.
Okay, so we'll get back to pulsars. Pulsars around 25 kilometres.
No, I really, like I said, wow. It's hard to believe that you think I think pulsars are an interesting subject. Because no. Couldn't care less.
In diameter and weighs a little bit more than our sun, which is about 2 times 10 to the 27th power in kilograms, a very big number. Billions of tonnes. Pulsars roughly 1.2 to 2 point something. The size doesn't matter. It's an evolution of a star. It's the result of a supernova. That's your neutron star. And they only become pulsars when they've got enough spin.
Yes, so I would argue that some of that makes sense in the sense that you could understand that a star supernovas because it's made too many heavy elements. It has too many nuclei in it now. And then when it explodes, all the little bits fly off, but the nuclei don't go quite as far and they recollapse. So now it collects all the heavier elements even more densely. So, and it's not on fire anymore because it's not making helium and all that kind of stuff. So it got rid of all the light bits, and now it's just heavy bits. And now it's just nuclei, frankly. So it takes all that helium and then just makes a bunch of helium nuclei and sticks those together and gets rid of all the electrons. You could make an argument like that even. So yes, I believe that they would be small and dense, but they're not black holes.
Factor and enough energy to accelerate the magnons internally to relativistic velocities.
Yeah, whatever. All this accelerating. It takes momentum. It takes energy to accelerate, to move things. So all of this swirly bits have to be explained and where it comes from. Where's the energy for all of that crap? I would argue that if we study these little tiny neutron stars, magnets and things, that you can learn a lot more. And it would be kind of silly for me to think that inside that magnet is some swirly engine. It's just swirling stuff all the time, swirling. No good reason to believe that. So, morning interruption, blah, 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 blah. Might as well pause it, I suppose. Let's just endure it. It'll be over quickly.
Hi, this is Gary. I can't get to the phone
Yeah,
right now, but you can leave your
fax
name, number, and a
machine.
message if you like. I'll get back to you as soon as I can.
The daily harassment. Now it's time.
Thank you for your call.
Yes, thank you. This is so charming. Humans are so charming. Anyway, continuing.
Speed of light, and they actually try and accelerate them faster, but you can't exceed the speed of light. So that is like a braking force, and that's
there's no braking force. So yes, obviously matter can only go as fast as it can be pushed. So it can only go as fast as the pushers. So if I'm a piece of matter, electron, I can be pushed. I can have stuff hit me and stick, sort of, and keep pushing in a direction that's overcoming everything pushing in the opposite direction. even if I get a million little pushers behind me, they can only push me the same speed they're going, the speed of light. So the fastest I can get up to is their speed. That's it.
Converted into energy frequency of the particle. So you're converting magnons into photons.
Might as well just quit calling them. Like I said, I would prefer force bit because it's all force bits. Then you don't have to worry about conversion names. And you can just say, well, photon is force bits at a frequency. And then you could say magneton is force bits that have been segregated based on whether they're electron force bits or proton force bits. See, my 2 + 2 + 2 physics works. So you're going to have a hard time convincing me I need to change it for some reason.
The next stage up from a pulsar is a magnetar. That's a pretty wild jump up in magnitude, many hundreds to thousands of times in mass. But here's the weird thing, is they're smaller. A magnetar is around 15 kilometres in diameter, and this leads me to the postulation that black holes, the actual physical black hole, is way smaller than 15 kilometres in diameter, and the inference is that the bigger the black hole, the more mass the black hole has, the smaller it is. The smaller it is, the more intense the gravitational field. And I hate to say it, but this is drawing me into temporal distortion, time dilation. I can see on the internet, I can go there now and you can see it. You can see
time dilation, what pile of crap. Again, time is just a function. You can't dilate, you can't change it. Everything has to move at these speeds. There's no place you can go in the universe where you change the rules. It's always the same rules, always the same time. Always, 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 always. And there's absolutely zero evidence that there's any place I can go in space and all of a sudden time changes and I'm not, oh, it's not 10:15 anymore. Nah. No, it's always 10:15 or 10:16 or 10:17. You know, it's always happening, always the same, always, always, always. And all you can do is, you know, you can have something really far away, and the only way we know something happened to it is it has to throw a bottle into the ocean. We have to wait for the bottle to get here. Didn't mean that the bottle wasn't thrown at 10 a.m. on Thursday. Yes, it was. Okay, the fact that it doesn't get to your shore until, 4 years later doesn't have a damn thing to do with when it was thrown in the goddamn water. So, the guy who wrote the note is 4 years older. Just a fact.
Actual pictures of gravitational lensing, and this has not been space.
Alright, whatever. It's the same difference, okay? Gravitational lensing. There's only, look, I'm arguing the only thing that can bend a force is it has to interact with an electron, a piece of matter. Has to interact with matter to change its direction. It never changes its direction because of any frickin' gravity or any other force. And here you're just basically just cooking the crappy recipe. Okay, so do you also believe that light is bent twice as much by gravity? By this lensing effect, that it's actually twice as strong somehow? It affects light twice as much as it affects an electron or a proton or an atom or a wrench or a battery or anything else in the universe, that light is somehow twice as bent by it? Do you believe that coarse crap? That made up babble?
The photon is trying to travel in a straight line, but it can't always do that because the actual space is getting pulled into it.
Yeah, whatever. Space to me is nothing. So again, you want to say you can pull nothing? Fine. I'm not going to believe it. I don't think that's reasonable. So call it your ether. Call it something else. Calling it space is just cheating the argument. To assume I have to believe space is glue or space is pea soup or space is some sort of goop that you can pull or bend, why do I have to believe that? Where did you prove it? Oh, that's right, you didn't do any of that. You've taken a simple word that means nothing and changed it into a something. Well, you're the criminal here. I didn't do that. You did that. I mean, do I really have to keep asserting? Do I have to call space the nothingness now? The vacuum? I can't even use the word vacuum, right? Because you people think vacuums do something. I mean, you're just so broken the language. You won't even give me words to describe nothing anymore because you're going to insist it has to be something. Ugh, it's so irritating.
Into the black hole. It's like, you reckon I talk about mermaids, so I've got this mermaid, I've told her to swim across a lake. She swims in a straight line, perfect straight line. So
yeah, I don't know why you do this part, right? I mean, this is so putridly patronizing. You don't think I understand the concept of gravitational lensing? I'm denying the existence of any such mechanism, okay, that there is any space sucker and that light could give a fuck. And I certainly don't believe it's doing it twice as much to a photon. It's just silly. Your images from space suck. Okay, they make no mathematical sense. There's no rigid geometry, no spherical geometry. Black holes get, they talk about, how smooth the surface of a black hole is, So it's supposed to be the smoothest surface you could ever imagine. It's so fucking perfectly smooth. And yet it creates completely bizarre distortions. This perfectly smooth gravity, this gravity that's so fucking smooth and consistent. Somehow, it creates crosses that are all crookedy. It creates, Einstein rings that are all wobbly. Oh, sure it does. What a pile of crap. And again, even Einstein said you're never going to see one of these things, so how the fuck are we seeing it? What magical principle took over to make it this gigantic, the ring, when it's supposed to be so infinitesimally thin that you would never be able to see it?
take this photon mermaid and we'll put her in a river. And we'll say, swim in a straight line. Now in the centre of the river, the current is moving faster than it is on the outside, closer to the shore. So she starts off in...
Yeah, so this is where we just diverge completely, right? I'm saying all the evidence indicates a force never interferes with a force. I can't shoot two laser beams into each other and make them fly all over the place. I can never take a force and bend another force with a force. So stuff going the speed of light could never, ever, ever be bent by any river. It's not possible.
A straight line. As she's swimming across, the current is getting stronger. Her actual path through the river, she's going in a straight line, but the space she's swimming in is moving. So
now, if you said the rocks are moving, and the rocks, are somehow, maybe the rocks could affect the field of the force, the stuff moving, the photons could be hitting electrons that are moving in a direction, and because they're hitting electrons that already have motion, they're being deflected all in the same direction. Well, I can maybe buy that, but I'm not buying this river affects river crap. Forces affect matter, matter affects forces, but matter doesn't affect matter, and force doesn't affect force.
It doesn't violate anything that you say. She's swimming in a straight line. As far as she's concerned, she's swimming in a straight line. She gets to the other side of the river, and she's downstream. Well, it doesn't matter how far, but anyway. The flowing of the river has caused the bending of her...
Well, so why can't we bend any of these other fields that are supposed to be moving the speed of light? You can't bend a photon field, you can't bend a magnetic field, you can't bend any of these fields. So why do you think bending fields is realistically a sensible answer? You can't bend charge fields, you can't bend any of these fields. Why do you think bending fields works?
Trajectory. So that's the explanation for gravitational lensing. It's the photon isn't moving, the medium at which it's moving through is moving. So
yeah, so forget it. We're already done, right? There's no medium. So whatever. No chance.
From now on, I don't want you to say the speed of force. I'd like you to acknowledge the speed of light, which is the same speed.
So what the fuck does that even mean? You'd like me to acknowledge the speed of light? I mean, I've made 2,000 videos. Where in one of those videos didn't I acknowledge the speed of light? And where didn't I say it over and over again that it's really the speed of force? All the forces move at the speed of light. So why are we saying the speed of light? If it's the speed of magnetism and it's also the speed of gravity, then why are we calling it the speed of light? Because it's obviously not the speed of light, is it? No, it's a function of all the forces. So it's the speed of force.
Speed as gravity and the same speed as magnetism. And my argument is that the energy particles within the gravity field and within a magnetic field do not have enough energy to be light and escape their contact.
Right, that's where we completely disagree, okay? You're saying that somehow you can change their energy. I'm saying, no, you can't. You can just shoot more bullets. If I shoot the bullets closer to each other, right, obviously more bullets fit in the same amount of space, right? So if I shoot bullets at 1/2 second, I'll have twice as many bullets in 1 second of space than if I shoot them once every second. All right, so clearly there's more energy in the sense there's more bullets. But it doesn't mean the bullets have more energy. Durr.
So I think I've presented enough evidence.
You haven't presented a single shred of anything called evidence. You've just told me what you believe. And I've explained to you why I believe something different. And I'm basing my beliefs on experiments that are reliable. I'm not telling you how neutron stars work.
You can go on the internet and Google neutrino experiments, or you can Google...
Oh, yeah, so fine. You know, I'll just say that to you. I'll just make a Google the double slit experiment. Google the, 1/2 mv squared. Google gravity. The Sage gravity.
Schwarzschild radius, and you'll see the basic mistake that they're making. They're assuming infinity. And my thought...
Doesn't matter. They're assuming matter doesn't have to be have a volume. They're pretending that all of these interactions are happening with things that have no physical size. And that's a big mistake, because their size completely decides, how much profile they have in the universe, what they can possibly collect. A point particle, an infinitesimally small point particle, can't interact with a field in the sense of something that's not a wave. If it's made of real photons, you can't collect them. Okay, if the bits, if it was a straight line force radiating on specific vectors, you can never hit a vector if you have an infinitesimally small point. It'll never receive any energy because you've made it too small to receive any energy.
What's on the matter of black holes is if we put every particle in the universe, observable universe, into a giant black hole, it would collapse to the point where it would be emitted as energy. The gravity itself would break and then be reborn as a...
Blah, 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 blah. I mean, clearly I don't believe any of that nonsense. I believe there's a certain amount of pressure in the universe, in the sense there's about... If I took a square meter of space, empty space, it has a certain number of photons and radio waves and gamma rays and different things flying through that 1 meter of space at one point in time. And that's the density. That's the pressure density of space. And you can't make more pressure than the pressure density of the space until you start creating one of these material objects where you're piling matter on top of matter. And now, as you make the radius, you make the diameter, make the circumference of the object bigger and bigger, now you're collecting pressure from more and more locations. So if it's 1,000 pounds per square inch that's hitting something, you can understand that if I make my surface have more and more square inches, then I'm going to have more and more pressure in the very center. And obviously there's a point where you have so much pressure, the stupid thing blows up.
A new universe, or a new part of this universe. There's trillions of stars in our universe, and there is more than one supernova every day. The point is we cannot detect them. We detect a few.
What do you mean we can't detect them? Yeah, they detect them all the time. So, can't predict them. That's the problem.
Sometimes if they're close to Earth, like the Crab Nebula in 1054, which was observed by the Chinese and written as the birth of a new star. I'd like you to study a bit of astrophysics. And
fuck you. Fuck you. I mean, fuck you. Yeah, fuck you. I'd like you to study a little bit of, basic symmetry and, straight line geometry. Yeah, take some algebra courses. I mean, what a pile of shit. No, I'm not going to waste. I've already had Carl Sagan waste enough of my time. All right, trying to do physics from out there. All right, physics is here, right here in front of you. I don't need to study anything other than this magnet. Right there is enough phenomenon to be explained. You don't have to go look at the big giant things because they're really not doing anything all that fucking interesting, frankly. It's not going to tell you that much.
Pure view of physics, and in my experience and education, you can never ever achieve infinity. You can approach infinity, but you can't achieve it.
Whatever that even means. Approach infinity. It just makes no sense at all.
Okay. Now, of course, gravity is under the rule of the inverse square law, and the distance obviously dictates the strength of the field.
It's not under a rule, okay? The fact is, it's under a phenomenon. There's a mechanism, and there's rational mechanisms that create the inverse square law, like when I turn a light bulb on. There's a rational mechanism that's creating. The light is coming from a small area, okay, and it's coming out in all directions. And that's the inverse square law. I can do it with my hand here, right? So why do I need to go out into space to better understand this phenomenon? I don't need to do that.
Obviously, the mass of the body that you're measuring, the gravity also. So we'll move along. And I named 3 objects which I believe to be manifestations of the same thing, and I'll offer some proof. Point of contention number 7, Tesla. He actually invented your and, or, not, nor, and exclusive, or logic gates.
Oh, bullshit. So whatever on that one. I mean, those were, frankly, discovered based when they were making those little cheap mathematical tools. So, you know, the fact that somebody applied it to electricity, fine. I mean, it's hardly, this was hardly, if you're going to say Tesla has the first patent on an electric logic gate, what do you think it would take 15 seconds after Tesla filed for somebody else to file the same patent? I mean, frankly, they already knew what an XOR logic gate was. It was just that, you know, we had applied it to mechanical switches, haven't applied it to electrical switches. So you're saying that Tesla did something insanely inventive there? No, nothing, not even close. That's why nobody even knows about the patent, is because it's so meaningless.
Every gate that makes up your computer was patented by Nikola Tesla.
See, just such baby talk that is. That's just weaselly nonsense to say, oh, we wouldn't have it without Tesla. Of course we were going to have it. Of course it was going to happen. As soon as they switched, an electric circuit on and off, they had already, telegraph. You could already say that telegraphs had already gotten pretty sophisticated in terms of creating those kind of logic gates. So you're so full of shit there.
So, and he also invented the three-phase.
There you go. That's the one. That's the one he should get credit for. Okay, that was the one good thing he invented. Was the magnetic motor. Essentially, you could really call it a magnetic motor. Let's see, what's a better word for it? I mean, phase just makes it complicated, but yes, okay, the fact that you could capitalize on taking advantage instead of having a motor that just switched from, that just crudely went in one direction, then you had to switch the polarity and switch it to, switch it and switch it. Yeah, you just take advantage of the fact that the out of phase of having a coil and then another coil, the more wire you have, the more out of phase they become, and you can sit there and just use coils to create a progressive, not interrupted magnetic field. A magnetic field that moves with the armature.
Phase motor based on...
But again, they're not great motors. I mean, they're only great motors for certain jobs because they have no torque. You can't use them in a lot of applications because they have no torque. They're only good when they're already spinning. They suck when they're not up to speed. When they're not up to the speed they have to be at, the one speed they can run at, they suck.
Rotating magnetic field geometry. So he was a genius engineer. A bit different.
Says you again. It's just such hype. He was an idiot. His theories were crap. Okay, and he had a really shitty attitude, frankly. He was just so full of himself. I mean, again, Einstein was asked the question, what's it like to be the smartest man on Earth? And he said, go ask Mr. Tesla. Yeah, because he was over. He was just so fucking fat-headed.
From Einstein, who was a genius theoretician. But so two different guys.
Yes, both of them way overhyped. Einstein didn't do shit really when you think about it. I mean, the photoelectric effect analysis was already done by so many other people, and all he did was put it together. I mean, all he did was say, well, what's the implications? Okay, this guy, the Nazi, whatever his name was, did all the cathode ray experiments, discovered the phenomenon that you could, create these X-rays by hitting a material with the electrons, blah, 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 blah. And Einstein just put the facts together and said, well, doesn't this have an implication in the sense that you really can't believe these are fields anymore, can you? I mean, you really can't play this wave game when, you have such an overt particle creating, with causing the effect. And in this discrete way, where only a certain amount is going to be created. It's either on or off. It's not waving.
Different fields of expertise, and both contributed greatly to our modern day.
Oh, bullshit. So again, Tesla's didn't in any way do anything. I mean, you're talking about the most innovative period. I mean, the world changed every year. There was a new invention. I mean, it wasn't like this was a time when inventions were, it wasn't like it took 200 years for somebody to finally make a video saying Young's diagram is bullshit, right? 200 years. So there's been a ton of physics that's been broken for a really long time, and no one fixed it. All right, but in this period, of the early 1900s, they were inventing things every day. I mean, to say Tesla was so much better than all of these other guys is just bullshit.
Physics. So, I've already said it, but I've written it down here. Contention number 8. No faster than light speed. And I say light speed, you cannot just generically use the speed of force.
Yeah, you can, asshole. So go show me one fucking example of something doing anything different. Show me a force moving, it's less than the speed of force. Show me that in free space.
Because there are forces that travel slower, way slower, than light. So
name it. Name the force doing that. Not the matter doing that. The force doing that, right? You do understand the distinction. Photons are whatever they're made out of. It's not matter. You got that much right? I mean, it's not the same. You can't put it in the same category. It's not an electron. It's not a proton. It's not a constituent of the atom in the sense that it's not one of those players. It's the thing moving the electrons and the protons. But you won't. There's no example of this slower force.
To call something the speed of force is that's your little pet naming convention, and it's wrong. It's just
you won't prove it wrong, so you can say it, but you're never going to prove it. So go ahead, show me the force moving slower than the speed of light, the exact speed of light. Show me. Show me. Show me magnetism doing that. Show me electricity doing that. Well, forget about electric. Electric's the movement of electrons. It's not a force. Electricity is a phenomenon. It's not a force. So where is charge? Or show me charge going slower than the speed of light. Show me magnetism going slower than the speed of light. Show me gravity going slower than the speed of light.
Another bit of paper here. And I speak English, but you don't seem to understand English, perhaps. Maybe I should speak American.
Or British. I mean, I can understand many of the Brits. So, yeah, if you just spoke the language you're supposed to be speaking, I would be more pleased. But regardless, close enough. I don't care. Minor point. I just don't know what you said. These are wild teeth. I don't know what a wild is.
In the previous video, I said proton when I meant to say photon. A little more.
Right. So when he was saying what something was made out of, it wasn't protons. It was made out of. So this is the ether or something. The ether is made out of photons. I don't know. Regardless, there's no ether.
I don't like the fact I'm getting drawn into this temporal distortion, but it appears to be the logical answer. And as they say,
whatever. No, I don't say it. So as they say are usually really bad news for me because it's not what I say.
truth is stranger than fiction.
Yeah, bullshit. That's what I say to that. The truth always turns out to be really, really mundane and boring, frankly. So I don't know. Where's the truth that's stranger than fiction? Except the truths that are bullshit, religious, nonsensical. All the truths seem to be really not very strange, frankly. Really simple, really benign, uninteresting, dull.
Anyway, Gary, that's about it. You can see if you can argue against that, and we'll talk to you later. Cheers.
Yeah, well, whatever. Cheerio again. But like I said, there's really nothing, I was interested in your, whatever it is, your new discovery that creates economical space travel. Don't need big rockets anymore. Don't need any of that troublesome nonsense. So that's interesting if you got it. You've got this new source of energy that makes nuclear power look feeble and silly. Go ahead, show me that. But yeah, otherwise, I have nothing against. I want to talk physics, but it has to be. Again, we just don't have any common references. I don't want to talk about the Garden of Eden. I mean, I don't want to talk about immaculate conceptions. All that's just not terribly interesting to me. So unless you can bring your physics to something I can accept as existing, like there's real evidence for it, fine, real experimental evidence. But otherwise, no, if you're just going to tell me Eddington was a good experiment and they proved light is bent by gravity, no, I'm not going to fall for that. And such. Okay. Cleaning up a little. There we go. Alright, sorry, longer than it probably needed to be, but it's the way it works. It's what came out. So till the next time, and such, and so forth and whatnot. Okay. No new comments of any merit, I don't think, so we'll call it a day.